Okay, this is a really short introduction to scalars and vectors. Kind of weird sounding words that make them sound complicated, but actually it's pretty simple. We'll start off with a working idea that vectors are things that have direction and scalars are things that don't have direction. Okay, it's that simple. So let's have a look at a couple of examples so we can get a feel for this. Look at some different quantities and see if we think they have direction or if they don't. So we'll start over here with temperature. Now when we're talking about a direction, we're talking about a physical, geographical direction like up or down or north or south, left or right. Can you have a temperature in a direction, up or down, left or right? I don't think so. Temperature is a scalar quantity, something that doesn't have direction. What about the mass of an object? 50 kilograms. Does that have a direction? Can that have a direction? Kind of, if it were the weight of the object, but it isn't the weight, it's the mass. The mass of an object I don't think has direction, so that is a scalar. What about a force? Can you imagine a force acting in a direction? Yeah, pretty much any force you can think of has a direction associated with it. The force of gravity on me is pulling me down. If I pull on a cupboard door, I'm pulling in a direction. Forces always have direction, so force is a vector. Anything you can represent with an arrow is probably a vector. The volume of an object, does the volume have a direction associated with it? I don't think so. Volume is a scalar. Now we get onto two interesting ones, speed and distance. Does distance have a direction? Well, sometimes it does and sometimes it doesn't. If you went for a 10k run, then you've covered a distance of 10 kilometers. Does it matter what direction you went in? Probably not. You could have run in a circle, you could have run from one place to another. The thing that's important for you if you're doing a 10k run is that you ran a distance of 10 kilometers. So in that case it doesn't have direction and it's a scalar. But on the other hand, if you're on a Duke of Edinburgh expedition, there's a real difference between going, for example, 10 kilometers north and 10 kilometers south. So in that case we've got a distance with a direction, and the direction's really important. So that actually gets a new name, which is displacement. So displacement is the vector version of distance. A distance might be 10 kilometers. That's just a distance that you've travelled. A displacement might be 10 kilometers north, for example, on a Duke of Edinburgh expedition. A similar situation happens with speed. Sometimes speed doesn't have a direction. The direction isn't important. The speed limit on roads in towns is 30 miles an hour. That's just a speed. It doesn't matter what direction you're going. The speed limit's 30 miles an hour. On the other hand, if you're flying a plane or something, a bit like the Duke of Edinburgh example, the direction you're going and the speed are both important. So we've got two versions of speed, the scalar version that doesn't have direction, and then a vector version if we give a speed with a direction. And that is called a velocity. So if we have a speed with a direction, that's a velocity. If we just have a speed on its own, that's just a speed. So these are just some scalars and vectors, but any physical quantity can be classified as a scalar, something that doesn't have direction, or a vector, something that does. Now, how can you describe this direction? Well, there's a multitude of ways you can give a direction. So if we start over here with this person, and we've labelled the force of their weight, the direction there, we could just give the direction as down. 50 newtons, by the way, is not very much. This would have to be a small baby, but anyway, I suppose that works with the ratio of the size of its head to the rest of its body. So we can give the direction just simply as down, or up, or left or right. Over here on this map, we've got a distance travelled in a direction. Maybe this is the path of a helicopter or something like that. In this case, we can give the direction of this displacement as a compass heading, northeast, or as a bearing, 045 degrees. So that's another option for giving the direction. Here we've got a cannon shooting a cannonball in this direction. The arrow indicates the velocity, that is the speed of the cannonball and its direction. And in this case, the direction is being described relative to either the horizontal, 30 degrees to the horizontal, or the vertical, 60 degrees to the vertical. So these are all different ways of giving the direction of a vector. I'm sure there are other ways as well. So don't just think that vectors have got to do with north or south, or east or west, or up or down. You can give the direction of a vector in all sorts of ways. Finally, we'd better do the full definition, because this is what you might need to regurgitate in an exam. So the full definition for a scalar is it's a quantity with magnitude only. The magnitude corresponds to the size, the number associated with it. So if a rocket has a thrust of 150 kilonewtons, the 150 bit is the magnitude, okay? Force, of course, isn't a scalar, though. It's a vector. So a vector is a quantity with magnitude and direction. So to make this into a true force vector, this 150 kilonewtons, we have to give it a direction upwards. So vectors have a magnitude, a size, and a direction upwards. Contrast that with a scalar, something like, you know, a volume of 50 meters cubed. That just has a magnitude, it has no direction associated with it. So those are the full definitions. Now you might want to just have a quick go at classifying some of these quantities here and seeing whether you think they're scalars or vectors. So pause the video here, try and classify these, and then I'll go through what I think they are. Okay, let's get started. So, weight. Well, weight is a force, and force we've already described as a vector, so weight must be a vector. Weight has direction. What about momentum? Well, momentum is mass times velocity, and velocity has direction. We've just discussed that previously. So momentum also has a direction. The direction you're going is extremely important for your momentum. So weight and momentum are both vectors. Time is an interesting one, because time kind of has a direction in that we can think of time as going forwards and backwards, but those aren't actual physical geographical directions like north or south or up or down. So time doesn't have that sort of direction, so it's a scalar. Charge, the charge of an electron or something like that, does that have a direction? No. That's a scalar. Pressure. Does pressure have a direction? Well, pressure in fluids kind of acts in all directions. It doesn't have a, a particular direction associated with it unless you have a pressure difference which creates a force. Now, force is a vector, but pressure alone isn't a vector. And finally, acceleration. Well, acceleration is related to velocity again, because it's the change in velocity divided by the time. So like velocity, acceleration does have a direction. You can definitely imagine an object accelerating in a particular direction. You can definitely imagine an object having momentum in a particular direction, whereas you can't imagine directions for the scalars. So that's a quick introduction to scalars and vectors. There's plenty more to come.